Hello everyone, myself Yobroto Manna, Assistant Professor, Department of Chemistry, Brennard University. Today's our topic is water chemistry. Before starting off this topic, here I want to mention one famous scientist quote, Ben Franklin. He says that when the well is dry, we know the worth of the water. Why he say that? Because if you look at the source of water, in our planet Earth, three part of each water, one part is land. Within this three part, water, 95%, more than 95% water is ocean water, and rest of the 3%, 3 to 5% is polar ice caps and the groundwater level. Both are very difficult to available for the living things in this world. So survival of living things, human, plant, or any living organism in earth need drinkable water. Now this drinkable water coming from this mainly from the underground water. But this underground water, if you look at this statistic, this underground water is day by day is decreasing and decreasing. So as the drinkable water, the groundwater is day by day is decreasing. Normally surface water and the groundwater day by day decreasing. So it become a massive threat for all the living things in this world. So that is why nowadays save water is one of the biggest challenge for us. So for survival of all the human beings, all the plant or living things, so water is a very much essential. Now if you look at the water in molecular prospect, it is 2 mole of hydrogen, one or 2 atom of hydrogen, one in a water molecule, 2 atom of hydrogen, 1 atom of oxygen is present. So this is sp2 hybridized compound where 2 lone pair of electrons is there, as they are very much repulsive in nature. According to VSEPR theory, it is reluctant to maintain the ideal tetrahedral structure, and it is a polar solvent and universal solvent, and it is due to the versatile use of water. So this is then we go to the next slide. In the next step, when we think about the water body as a drinkable purpose, some water parameter is much more essential to know. Color, odor, taste. Normally color of the water is white, and it is odorless and tasteless. And turbidity, there is so many organic, finely driven organic materials, slate, clay, sands, suspended aggregates are there. So this is sometimes is very turbid in nature. Temperature, water temperature is one of the essential things for any living organism, because metabolic and reproducing activities in water is very much depends on the temperature of the water. Now, if you want to know the chemical parameters, the chemical parameters is come to our mind is the pH of the water. Any drinkable water should be pH around 7, because it is a neutral pH, and any water tastes because it is neutral pH 7. Another one of the essential thing is the amount of chloride presence. If it is exceed 250 milligram per liter, so it is not drinkable for human. So chloride presence within the water must be a limiting within the limit, that is 250 milligram per liter. Another is hardness. If your water body content calcium, magnesium, iron carbonate or sulfate or chloride, these are responsible for the hardness of water. And this hardness may be sometimes permanent hardness and temporary hardness. Which particular salt is responsible permanent, and which particular salts are responsible for temporary hardness, we will discuss that later on. Another thing is very chemical parameter is very much essential for water, that is dissolved oxygen. This amount of dissolved oxygen, if it is lower within the limiting value, then it is very one of the disaster for the living organism within the water. But that amount of water, that water which having the low amount of dissolved oxygen, when we intake it, making so many create so many problems within the human body also. So water, how much amount of dissolved oxygen within water we have to monitor by, we can monitor it by the two way. One is a biological oxygen demand, where in 5 days we will at 20-degree temperature we able to find out how many organic waste is present, and that can be measured by the help of the organism present within the water. And if the organic whatever the organic material is present is high amount, then the water body will be polluted, and the BOD value will be much more high. Another thing is find out the dissolved oxygen, chemical oxygen demand. Where chemical oxygen demand, there we consider two things: inorganic material and organic material present within the water. That is why COD value is much more higher than BOD value. So for that case, we use a chemical, mainly the oxidizing compound, that is potassium dichromate, potassium permanganate, and where we able to find out the quality of water by measuring the dissolved oxygen. And another thing is fluorine content. If the water body contain high amount of fluorine, that is more than 1 milligram per liter, then that water also very much not drinkable. Drinkable. So these are the chemical parameters. Apart from that, now we state another chemical parameter that is also very much necessary for any types of water. That is alkalinity. Now, what is alkalinity? Alkalinity is nothing but a presence of sodium hydroxide and sodium carbonate within the water. Okay, if these two compounds present within water, that it is alkaline in nature. But your water, whatever you are drinking, that water should contain a limiting value of these two compounds. Okay, now if it is exceed, then that is not permissible. So how much sodium hydroxide, how much sodium carbonate present within your water, that can be measured by simple acid-base titration, where we use two types of indicator. One is phenolphthalein indicator and methyl orange indicator. And for doing so, we have to take a Koneken flask, where we have to take known amount of alkaline solution, and that alkaline solution is titrated against known strength HCl solution using phenolphthalein first. And for that case, when we add phenolphthalein, it is pink in color. It is already given in the here, that is pink in color. And when we start titrating this solution with standard is HCl solution, then this is a particular time will come when it is converted to white color, colorless, pink to colorless, with the presence of the indicator phenolphthalein. Now, within these things, what is happening? If you look at the reactions over there, when we are adding HCl by using phenolphthalein, that is whole sodium hydroxide and half of sodium carbonate is neutralized. Half of sodium carbonate and full sodium hydroxide is neutralized during this phenolphthalein indicator titration process. Okay, then how much amount of sodium bicarbonate is present? If you look at that this particular reaction, that whatever the sodium carbonate is present, half of it is already neutralized by the using phenolphthalein indicator. We have done it. Then rest of the sodium carbonate we can titrating by methyl orange, where the pH level is quite low, and that pH level we use another indicator, which is methyl orange. When we add your solution is colorless, like this, colorless. Now you are adding methyl orange. When you are adding methyl orange, the color is yellow. This yellow color, these types of yellow color. Okay, yellow color. Now, if you standardize this continuous standardization, then by standard HCl solution, this color changes to orange in color, and you have to stop titration, and then you have to take the previous value and the final value. We started with from say 0. Then for phenolphthalein purpose, we get one value that is say V1. That V1 for the volume of HCl required for the half neutralization of sodium carbonate plus volume of HCl required for the complete neutralization of NaOH, where we use phenolphthalein indicator. That is V1 value. Then we continue the titration with the methyl orange indicator, and then from where the value of HCl required for methyl orange indicator is equal to volume of HCl required for the half neutralization of sodium carbonate, that is sodium bicarbonate. That is nothing but V2 minus V1. Now, volume required HCl required for that complete neutralization of sodium carbonate, that will be the twice of this value. That will be twice of this value. Okay, so that is 2 into V2 minus V1. Now with simple V1 is 1, V2 is 2, we able to calculate the amount of sodium carbonate is present over there, amount of sodium hydroxide present over there, and that can be the total amount of sodium carbonate and total amount of sodium hydroxide can be calculated in gram per liter also by using this formula is given here. So this is alkalinity, and this alkalinity should be in the limiting value. More than that, that will be that water not drinkable in nature. So this is alkalinity of water. Another things we have already discussed, this is another chemical parameter, that is hardness. We have already told that hardness responsible for the calcium, magnesium, iron, bicarbonate, chloride, sulfate, salt, right? So temporary hardness normally bicarbonate, this calcium, magnesium, iron, bicarbonate. Most of the time if you boil it, this bicarbonate is converted into carbonate, and carbon dioxide may go out and the water become the drinkable and soft in nature. But if the permanent hardness is there, that is responsible for the carbonate as well as the chloride and sulfate of this particular metal, so that is a big problem. If your water contain permanent hardness, so that permanent hardness is make low amount of foams in water, and that also washing purpose, if you use this permanent hardness content water, so that is wastage of your soap or detergent powder for that case. So that is why hardness measurement within the water is one of the essential things nowadays. If your water contains high amount of hard material, so that is also not good for the drinkable purpose also, drinking water also. Normally this we can measure hardness of water in 1 part of calcium carbonate to 1 to 10 to the 6 part of water. So 1 milli equivalent of calcium carbonate equal to 50 milligram of calcium carbonate. We use calcium carbonate because it is pure, it is insoluble in water. So your molecular also one of the function that we use calcium carbonate as a unit purpose for measuring the hardness of the water. And to find, there is so many process by which you can able to find out the amount of hardness water in the hardness present in the water. The first one of the famous technique is the EDTA method. In EDTA method, what we have done, if we take known amount of sample water in a particular conical, and if we maintain that medium around the pH 10 by by adding some buffer, ammonium chloride, ammonium hydroxide buffer, then we if this water contain some amount of calcium, magnesium, salt within it, so that calcium, magnesium, salt, if we add indicator, EBT indicator, eriochrome black tea indicator, that color will be of that solution will be wine red, this color. And if we treated this solution by EDTA, ethylene diamine tetraacetic acid, known strength of this solution. So we titrated this particular things with this EDTA. So that will at the end point of this titration, the blue color exists. That blue color is for the free EBT color. What is the chemistry behind it? When we are taking water sample in conical and we are adding the EBT indicator, then whatever the magnesium or calcium present that react with EBT forming calcium magnesium EBT, and that is the color of this complex is wine red. And when we started titrating by EDTA, known strength of EDTA, this metal EBT, that is wine red color, converting to metal EDTA, because metal EDTA complex is much more stable than metal EBT complex. So when it is converting to metal EDTA, then EBT become free within the solution. So that is why this particular color we will show, that is still blue color, that blue color is responsible for the indicator. So at the endpoint, that there is working formula is given, as we know the normal V1 is on V2 is to principle. So we can able to find out the amount of magnesium, total magnesium calcium present within the water in ppm unit also. And if it is a permissible level, it's okay, but if it exceed, then that water is not drinkable. Apart from that, there is another process is there where we can measure the Oehners method, where we can measure the temporary hardness as well as the permanent hardness also. Normally we know the temporary hardness is responsible for the calcium, magnesium, bicarbonate present, where if we heated that particular water solution, that will form calcium carbonate and carbon dioxide, and that calcium carbonate is not soluble in that medium, so it is precipitated out, and rest of the part we can normal using by the any standard EDTA solution. We can also measure the amount of permanent temporary hardness, and as well as we can also calculate the permanent hardness present within the water by the Oehners method, where say if your water body contains calcium chloride is a permanent hard material. So for that case, with some amount of, in that case, some amount of known amount of sodium carbonate is used, that converting calcium chloride into calcium carbonate and sodium chloride, and that calcium carbonate is precipitated out, and in that manner by knowing strength of HCl using methyl oil indicator, we can also able to find out how much amount of hardness present within the water. So Oehners is another method by we can also able to find out the amount of temporary as well as the permanent hardness within the water. In the next step, now when this hardness present within the water, it become a big problem because as I say, not only drinking purpose, one of the another use in mankind for water is water is in so many industrial purpose. Mainly water used in the industry in boilers. So when this water contains these types of hard material, chloride, magnesium or calcium salts are there present over there. So this boiler is very much affected by these types of salt. So what actually it travel the boiler by forming the scale, sludge, foaming, priming, and that become the corrosion within the boiler. And normally, which particular compound is responsible for the sludge? It is magnesium carbonate, magnesium chloride, calcium chloride, magnesium sulfate. And scales are the calcium carbonate which is insoluble due to the formation of calcium hydroxide within the pressure and temperature within the boiler. And that is this soft, they forming two types of scales. One is soft scale, another is hard scale. Soft scale mainly magnesium hydroxide and calcium hydroxide, and hard scale are very much tough to release from the boiler. That is mainly calcium silicate and magnesium silicate. So it is sticked within the inner wall of the boiler. So what actually happened, there is a picture, you can see that. When it is stuck in the inner portion of the boiler, so there is a layer is forming. That layer is one of the form. It is when it is forming layer. So uneven expansion of the thermal expansion is there. So that this is one of the big problems of forming crack within the inner wall. Another thing is we need for a high amount of heat, that is wastage of fuel also, and it is also a big threat for the boiler also. Sometimes it's explosions is there due to the presence of these types of within the water. And as I say, when we have in industry so many boilers are working in condition, but we have to use some water source, maybe river water, maybe ocean water or pond water. That water contains these types of salt. But we have to think about how to protect this boiler from these types of salt. For doing so, so many processes are there. One of the process prevention technique we use for that. There is a very simple thing, is a blow down operation. Blow down operation is very simple. There is a outlet is there in the top portion of the boiler, closing the inner and outer outlet. What actually we do, we inputting fresh water within the boiler, and all the scalds, all the sludge which is maybe removable, easily removable, that is washed away in the lower portion of the boiler. And there is one of the outlets should be there, that we open this outlet, that all the sludge and is clean and washed in that way. So this is the blow down operation, and this blow down operation is also fill up process also. Then you can fill the boiler with water. So this is a simple process. Apart from that, there is so many internal treatment or conditioning, and external treatment and conditioning is there. In internal treatment and conditioning, there is phosphate conditioning, calgon conditioning, and carbonate conditioning is there. In external, there is permuted process, zeolite process is there, ion exchange process is there, desalination or brackish water is there. So we will discuss these things. So in phosphate conditioning, normally we use three types of sodium phosphate salt. One is trisodium phosphate, disodium phosphate, and sodium hydrogen phosphate. And when this phosphate react with metal chloride, MCl, or metal sulfate, they will forming metal phosphate, and sodium chloride, sodium sulfate is liberated out. And when they is forming metal sulfate, this is precipitated out, and we can separate them easily. And NaCl, sodium sulfate, is soluble in water. They will never ever affect your boiler. So phosphate conditioning, one of the very essential process by which we can protect our boiler from this harmful chloride and sulfate. This is one. Second, calgon conditioning. Calgon is one type of compound, that is sodium hexametaphosphate. This sodium hexametaphosphate at a particular pressure and temperature, normally it is responsible for liberation of sodium sulfate. That sodium sulfate is not harmful. When it is this sodium hexametaphosphate react with those hard salts like calcium sulfate, I am giving one example here. There is one example is given over there. So it is forming sodium calcium metaphosphate, and sodium sulfate is liberating out. And as I already mentioned earlier, that sodium sulfate is not responsible for the any harmful effect on the boiler. But we can separate calcium from that that water source. That is the main thinking of this particular purpose. Another is sodium carbonate conditioning. So in normally low pressure boiler, we use this technique where we use sodium carbonate as a material that react with so many hard salt, calcium sulfate, or maybe calcium chloride, and forming calcium carbonate or sodium sulfate. And that calcium carbonate is precipitated out. By blow down process, you can easily wash them from the boiler. And if it is contained sodium sulfate, that's not a big problem, because sodium sulfate is not creating any types of problem within the boiler. So in that internal conditioning process, we can protect our boiler from this harmful salt, hard salt. There is so many external conditions also there. Those external conditions are mainly permuted process or zeolite process is one of the essential process. Where what is zeolite? Zeolite is a Zeolite is a trade name. It is one of the composite of sodium aluminum silicate. Normally, general formula is given over there. It is by the varying x, y, we can make different zeolite, different types of zeolite. One of the natural zeolite is given over there, it's quartz. We use so many artificial zeolite depending on the what types of hard chemicals are present within your water. So that what actually zeolites do, zeolite bed contains sodium, that sodium jet, that sodium salt of zeolite. When it is react with that salt responsible for the hardness of your boiler water, that I am taking here calcium anisole, calcium sulfate, or calcium chloride, or magnesium sulfate, magnesium chloride, whatever you take. So it react, it will form calcium zeolite. That means zeolite head, so head is made of sodium. That sodium is totally replaced by the calcium. So that calcium, where from it is coming? From your boiler water. And that you want, that if you want to separate that calcium from the boiler water, it is done. So, so the water become much more usable for boiler water purpose. So that sodium zeolite is converted in calcium magnesium zeolite, and sodium salt is forming, and sodium salt is not responsible for any types of harmful effect on the boiler. So, so this is the process. Now, now we can regenerate this zeolite again by using magnesium chloride salt, adding magnesium chloride or sodium chloride on it. So that case, the calcium magnesium zeolite is converted to sodium and sodium zeolite. So you can reuse this material. One of the green approach of this particular technique is that we can reuse that zeolite compound again. So this is one of the process we can use for the protective measurement boiler. Ion exchange process. Ion exchange process is another process where two types of this is synthetic polymer we use actually. That synthetic polymer actually is one type of resin. That resin content, one is cationic head and anionic head. And if it is cationic head, that mainly SO3, H plus, COOH, those particular groups are present. And if it is anionic exchange resin, then it is contain NH2, OH minus, these types of compound. But if you look at this reaction, that it is much more easier to you to understand this thing. That if you use cationic resin that react with the hard salt like magnesium sulfate, where magnesium is sticked in the head of the resin, and H plus is and H2 super is liberated it out, and that is not harmful for the boiler water. But what is harmful? Harmful is your magnesium, harmful is your calcium. That calcium is separated like zeolite. Here we use resin. That calcium and magnesium is separated out. We can regenerate. Here also we can regenerate it by using dilute HCl H2 super 10% NaOH. We can also convert this particular used cationic or anion exchange resin into its previous condition. And there is a given, and this is another one of the important techniques by which we can use that. And desalination of brackish water. Desalination of brackish water is normally done with the ocean water, or maybe water where water body contains very high amount of dissolved solid. Maybe depending on the normal fresh water, it's contained 1000 up to 1000 ppm of solid bodies. But if it is brackish water or sea water, that contain more than 1000 ppm of solid things. For sea water, it's very high. 35,000 ppm of solid. So that is why I am telling in the beginning of the class that if your water body contain high amount of this concentrated salts, so this water is not drinkable, not usable on any purpose. And if you use that, then you need to go through this this particular separation technique. Then you can use it. Mainly seawater nowadays we are using for the industrial purpose. But we have to go through the desalination. Desalination is a process where we can separate the solid metals from the water. So there is two processes there we use normally. One is reverse osmosis. Reverse osmosis is a is the technique, a process where, where we use the pressure greater than osmotic pressure and we apply it at the high concentration site of the membrane. The flow of solvent molecules from concentrated site to the dilute site across the membrane. Where we use the membrane is a semi-permeable membrane. That semi-permeable membrane mainly made of polymethyl acrylate, cellulose acetate, polyamide polymer, like these types of material that allow only solvent molecules. So all the solvent molecule may be separated it out by using pressure greater than osmotic pressure. So this is the reverse osmosis. Nowadays, here I want to mention. Here I mentioned the drinking purpose, the industrial purpose, but drinking purpose, these things, this particular reverse osmosis is a very much essential nowadays. Reverse osmosis, and another thing is electrodialysis. There also we use two types of resin: cationic transfer membrane resin and anion transfer membrane resin. Then where cationic transfer, it is a fixed set of H plus, SO3 plus, and anionic, it is NR3 plus, OH minus. So many heads, negative and positive heads is there. So there is so many in a electrolysis process. What actually, there is so many electrodes are there where these cationic and anionic transfer membranes are present within the electrode, and in a particular applying voltage, they will separating all the metal or from its salts. So cation and anion can be separated in different portion by the electrodialysis process. So electrodialysis process, not industrially but also in drinking purpose. So many filter nowadays we use, where we use these two techniques very much: reverse osmosis and electrodialysis process. That is also we use for our household, so many purifier, water purifier machine, as well as industrial purpose. In large scale we use this technique by which we can save our boiler from this harmful salt present within it. So thank you so much for this lecture. This lecture content this particular things, where I will recapitulate everything once again. What we have discussed here, we have discussed in this topic that water, necessity of water, which parameter needed in our water, which particular parameter is not needed for drinking purpose. Normally we industrial use of this water, here we have discussed, where we have seen that hard water, normally so many metal salt is responsible for harmful effect in boiler, where we have explained all the technique by which we can save our boiler from this harmful effect. Thank you so much. Thank you.